In this lesson, we're going to work on proofs that use parallelograms. So first of all, you have to remember the parallelogram properties, because if you're given a parallelogram, there's lots of different things that you can conclude knowing that you have a parallelogram. So most common for a parallelogram is that the opposite sides are parallel. Also, a common property is that opposite sides are congruent. So those are probably your most common properties that you're going to use for parallelograms. But remember, opposite angles are also congruent. Consecutive or angles next to each other are supplementary. The diagonals bisect each other. And one diagonal will divide the parallelogram into two congruent triangles. So if you ever have a situation where you have a diagonal drawn in a parallelogram, the two triangles that are created are going to always be congruent. So let's look at a couple examples here using parallelograms to make conclusions. So the first thing here is it tells us that JK, so JKLM, is a parallelogram. So right away I know all of those properties above are true for this parallelogram. We know that JO, so JO is congruent to OL, and I want to prove segment OP is congruent to segment OQ. So right away, I'm looking at that and I'm thinking, in order for those two segments to be congruent, we need to go back and think about congruent triangles. If I have the triangles that those sides belong to congruent, so if I look at this green segment, that belongs to this green triangle. And if I look at this purple segment, that's going to belong to this purple triangle here. So if I could prove that those two triangles are congruent, then by CP/CTC, I could say that these segments are congruent. So that's where I'm going to go with this. So let's start by writing our given. So we have JKLM is a parallelogram. I really don't like using the symbol for parallelogram because I think it looks confusing as if it's really a parallelogram or is it just a quadrilateral. So I'd rather see you write out the word parallelogram, use abbreviation, but I don't really love the symbol because it's kind of confusing. So we have a parallelogram, and then we also have JO is congruent to OL. So I need to be able to get these triangles are congruent. So we have our different methods that we can use. Side, side, side. So just kind of a refresher here. Side, angle, 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 side, and HL. So right away I know I have one set of sides. So that doesn't really eliminate any options. But I see that I have a parallelogram. So I'm thinking, okay, well, what can I use from up top here? So opposite sides being congruent, that's not going to really help me because the parallelogram sides and the triangle sides are not the same. But if we looked at choice number 1 up there, opposite sides are parallel, that could help me because if I knew that these two sides here were parallel, which they are in a parallelogram, that's going to give me some alternate interior angles, which I can prove congruent. So what I'm going to do is I'm going to say JP is, well, actually, let me go ahead and just say the entire side. I don't want to use JP yet. I'm going to use the entire side. So JK is parallel to ML. And my reason for that is because a parallelogram, so since I'm given a parallelogram, it's coming from a parallelogram, I know that opposite sides are parallel. Or you could just write out parallelogram has opposite sides parallel, something like that. So then from there, now that I have these parallel sides, I can go right into saying, well, this angle 1 has to be congruent to angle 2. See the Z shape? You could also do the same thing for angles 3 and 4. I could say that those are congruent because, again, the Z shape. So it's up to you. So I'm going to use angles 3 and 4 as well. I'm going to list it all as one statement. So I'm going to say angle 1 is congruent to angle 2, and then angle 3 is congruent to angle 4. My reason for this is I have parallel lines. So even though these JP and QL are the parallel sides of the triangle, they belong to the entire side, JK and ML. So I'm not going to worry about changing this to say JP is parallel to QL because these segments will still be parallel if they're on the larger segments. So I'm going to go right to saying we had the parallel lines, which implies congruent alternate interior angles. So then from there, if I look at my picture, I have angle, angle, side in both of them. So this is going to be my method. And if we actually highlight, we have an angle, we have our other angle, and then we have our side. So now I can conclude, I can take these and pull them together, and I can say, well, that's going to make triangle JPO congruent to triangle. So be careful with which letters correspond. J is going to correspond with L, and then 4 and 3 correspond, so Q and then O. By angle, angle, side. And then from there, I can say that that makes those corresponding segments congruent by CP/CTC. So then these have to be congruent because corresponding parts of congruent triangles are congruent. So that's kind of going back to your congruent triangle proofs, but you're using these parallelogram properties to make conclusions. Now, you might have also been thinking, couldn't I use vertical angles? And yes, you could. You could call this 5 and 6 and say that those are congruent because they're vertical, and then it would have been angle, side, angle. That would have been an option. Or you could have used 3 and 4 with the vertical, and it would have been angle, angle, side. So different ways of doing it. It's just depending on what you see. So let's try one more together. So this next example here, we have a parallelogram. So let's first highlight that. So we have AB, CD. So this right here is a parallelogram that's given to us. So again, thinking about my properties right away, opposite sides are congruent, opposite sides are parallel. Those are going to be your most common. We have a diagonal that's dividing this into two congruent triangles. So I know that these two triangles have to be congruent. So there's different ways that we can, different properties we can use. We also have that D is the midpoint of DE, which doesn't make sense. This is supposed to say AE, so let's just fix that. So D is the midpoint of AE, so that means these two parts are congruent. And our end goal is to prove triangle DCE. So let me highlight these, DCE. So this triangle, I want to prove that that triangle is congruent to CDB. I'm trying to prove those two triangles. So right away I'm seeing reflexive property. I'm seeing a shared side, so we can mark that. And that's really about it of things that are pretty obvious. So that means I need to really focus on the fact that I have this parallelogram and how that's going to help me. So we know opposite sides are congruent. So the fact that I know these two parts are congruent would also would help me, because if this is a parallelogram, AD and BC have to be congruent. And if these are congruent and these two parts are congruent, well, then that really means the two sides of my triangles have to be congruent. So that's going to help me. And then we can look for maybe the use of parallel lines to help us. Maybe we have some congruent angles there. So let's start with using what we have. So let's go ahead and write down our given here. So I have ABCD is a parallelogram. So that's given. We know that D is the midpoint of AE. So that's given. So we've already made some conclusions. So let's talk about those. So we have our parallelogram. We knew right from that that AD is congruent to BC, because opposite sides, so a parallelogram implies opposite sides are congruent. We also had, because of our midpoint, we concluded that AD is congruent to DE, using that given. Midpoint implies two congruent segments. And then from here, we had the fact that in my yellow and blue triangles, B, C, and DE have to be congruent because if you look, we used AD twice. So since these two segments are congruent to AD, that makes them congruent to each other. So BC has to be congruent to DE by substitution or transitive property. Two things equal to the same thing have to be equal to each other. So that's why that's true. And then we had our reflexive property. So we had DC is congruent to DC. So from here, we have two sets of sides. So we have to decide really, are we going to be using side angle side or HL? Because those are the only two that have side angle side, HL, or side 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 are the only ones that have at least two sets of sides. So we have to ask ourselves, well, what else can we use from that parallelogram? So the fact that we have the opposite sides congruent, that get us two sets of sides. Knowing that these two sides are congruent isn't going to help because we already know that this side shared in both triangles. So if we think about the parallel, if this side is parallel to this side, that really means that this entire line is parallel to this entire line, which means if you look in your triangles now, see the Z shape? So you have the Z shape right here. So that means that angle 1 would have to be congruent to angle 2, which would get us side angle side in both triangles. So that's what I need to do. So I'm going to use the fact that we had the parallelogram. So this is going to look a little bit messy just because of the space here. So I'm going to conclude from here that we have the opposite sides are parallel. So we had AD is parallel to BC. Again, parallelogram implies opposite sides are parallel. And then from there, I can say that's going to make angle 1 congruent to angle 2 because we have parallel lines, which imply congruent alternate interior angles. So from here, this is going to be enough information to be able to get side angle side by taking my congruent angles, my reflexive property, which was one set of sides, and then my other set of sides was using the parallelogram. So from there, pulling all of this stuff together, we end up with triangle DCE is congruent to triangle CDB. That is going to be by side angle side. So we have it using that parallelogram twice to make conclusions was necessary so that we could get that third piece of information, which was that other angle, that other pair of angles. So go ahead and try the check your understanding problem, and we will do more with these kinds of proofs in class tomorrow.